This will be kind of a build video for this Vincent. Not really a build video, just going to show some details inside. When I was going through the last build up of it, I shot some video of it, and I'm going to edit those into this little intro thing. I want to mention some significant changes I made. Originally, this little heartbeat display was controlled by an Arduino. I've changed that to a little Pickaxe 08 M2 board on the back side of it. The sound effects are also controlled by an 08 M2. That little board right there, this one in here with the LED on it, has a 08 M2 under that little stack. Here's a previous version of a board I built for doing it. It's a DF player, which is a little MP3 player. You can buy fairly reasonably. And under it is a little 8-pin chip. That's a Pickaxe 08 M2. It's a little microcontroller that runs a basic programming language. This is its programming socket right here. You just plug a 3.5 millimeter jack that's hooked up to your on the programming cable. This is a little header. The one that's in there now is I changed it. This is the first version. That's the second version. Anyway, it plays with sound effects when it gets a signal from our receiver board, and also when it gets a signal from a receiver board into a different pin, it plays the laser sound effect and lights the LEDs from another pin. Each LED has its own 220 ohm resistor in line. I might do a separate video on this little board showing how easy it is to program it. It was surprisingly easy. The board, I made the board with my 3018 CNC. I designed the schematic and then the PC board in Easy EDA. This is a jumper for something I had to fix on it. But I designed those in Easy EDA, then with isolation routing, milled out these paths in between the tracks. It's called isolation routing. And soldered it all up. This is the DF player right here. Takes a SD card that you put your sound files on. Here's a little 08 M2 microcontroller, same size as a 555 timer. Now the Pickaxe is not as powerful as an Arduino. It's much slower, but most of the projects like these, it's fully capable of doing. It's a little bit easier to understand than an Arduino. You don't have to tackle the C+ programming language. But anyway, I'm gonna start showing the video. I'm gonna edit in the videos I did while I was building up this whole stack the previous time. Hopefully that'll be enough information to anyone who wants to build it. It's not an easy build by any means. There's so much wiring, and you have to wire it with connectors and things so you can actually work on it or take it apart, or at least I did. I guess it's possible to just solder it all together. That's not the way I did it. So that's what will follow this little intro. Since I've got it apart, I'm going to show some of the wiring inside. These black and white or black and red wire here and the black and red wire here are for the motors, the left and the right motor. They come up to this plug, which will plug into the board in this position right here, marked P1. That'll give you your motor control. The batteries, there's 2 batteries in one leg and one battery in the other. They're all in series. So these pair of wires and these pair of wires are from the batteries. Since they're hooked in series, the black goes to red here. And then you get your ground over here. This big mess right over here that I've made up. But this is a positive wire that'll give you your 3 cells or 4.5 volts. And it goes to a switch, and out of a switch up to all these pigtails that run for the boards. This little one, short one here, plugs into a board here. Yes, plus and minus. This one here plugs into the DF player board for the sound effects right here. Well, it goes like this. And this one right here goes into the little heartbeat display board like this. I just used the plugs I had. I didn't do anything special. It's kind of a nightmare, but it's always going to be a nightmare when you're wiring up something like this unless you really have the time and the parts to do it right. Or at least that's the way mine turn out. So that's the inside of it. I'll show a little bit of a detail on the boards before I put it together. This is the our receiver board. And I went ahead and mounted the 28mm speaker for the sound effects on the bottom of it, because that'll come out about in the right place. It'll extend out the back. I'll put some holes in his back panel to let the sound out. Hopefully it'll sound all right. This is the DF player board. It's got the DF player on top. Here's the programming jack for the pickaxe. Pull that out. You can see the pickaxe microcontroller underneath it. The speaker plugs in right here. The speaker wire there. Here's the pickaxe controller for the LED matrix. This is just it's a pickaxe OADM experimenter board, I think what they call it. But I've whacked or cut down. They start out, well, here's one that's got a bunch of wires added to it. But they start out like this. I've basically cut this bottom half off, and then just ran jumper wires to the 2 LED matrices. These matrices, they are soldered to this little piece of, here's the one I cut it out of. I cut out a piece of that board. These matrices have a pin header on the back, and then I just put them through the pin header and soldered them together. These little wires are 30 gauge wire wrap wire. I used to do some wire wrapping projects, and all I've done is tied these 4 pins here and these 4 pins to get here. This one goes to this one. This one goes to this one. The third one goes to the third one. The fourth one goes to the fourth one. So basically, you're just they're marked. I don't know if you'll be able to make it out, but they're marked positive, negative, data, and clock on each one. So all you're doing is tying the positive to the positive, negative, negative, data, data, clock, clock. And then to wire it to the pickaxe, you come off the positive to the V over here, the negative to the ground, the blue wire, I can't remember which one's clock and which one's data, but you put them to their right places on these boards. You only have to go to one board since you've tied them together, the data lines and the clock lines. I hope that makes sense. And here's the power for it, and that'll plug into this. Here I have it further assembled. Here's the DF player board with the pickaxe microcontroller, the heartbeat display with the two LED 8x8 matrices and the pickaxe microcontroller controlling it, the receiver board. Here's the motor that extends the lasers. Here's the motor that turns the head. We'll turn it on, turn the transmitter on, turn the receiver on.
Vincent's my name, sharpshooting's my game.
Played its message, it started a message, heartbeat monitor's going. Let's see if it works. Those are the drive motors. This is a head motor, head rotate motor. Here's the laser extend motor with the slip clutches on it. Sorry about hitting the camera. Now the two sound effects, and this button here fires the lasers. It's just got an LED hooked up to it now. Plays a sound effect. This button here should play a sound snip.
Vincent's my name, sharpshooting's my game. Out of the frying pan, hopefully not into the fire. They also serve to only stand and wait.
So that's what I've got so far. I'm going to stop the video, assemble it up in more of its final position, and then shoot a little more. I've built up the next section of Vincent here. I still got everything going. I've added a little distribution board so that I can take these laser beam guns, whatever you want to call them, LEDs, and run them off of one output and still be able to take them apart after I get the model built up. So they each individually plug into this board here. One of the problems of making something like this is you need to be able to take it apart, and probably many times as you're building it. So you can't just solder wires together that are going to be intertwined with other things. That involves connectors, and that's a lot of trouble. You can see I've added this board here that the DF player board mounts onto. I had to do some modifications to get everything to fit there. Well, I'll go ahead and show the next step after I get it assembled a little further. I guess I should explain these wires a little better. The blue and the white wire are coming from M3 and M5. When they go when they go low, it'll pull this input to the pickaxe low, two different inputs, and it'll trigger an action, either play the sound snip or do the laser thing. Well, I've assembled it a little further. I put this midsection on with the lasers that extend, and you can fire them.
They also serve to only stand and wait.
All the other stuff's still working, seems to be. Some things to note on this part of the assembly. To keep these from coming out, these little lasers, there are screws going down into a groove right here. So this is like a 10mm screw, I believe it is, two of them that fit into these slots and keep this captured. What else was I going to say? Oh, the screw right down in here, it's kind of a bear. Need to make sure I don't short anything out. it holds, it goes through the little heartbeat thing, through this and into the bottom to help hold it all together. So that's kind of hard to line up. There's this little monitor working. Show it from the front here. Well, I'll continue the assembly and stop at the next section. I'm getting ready to assemble this top part to the mid part. I've got the arms in there, and to put tension on those arms so that they, hopefully they'll be posable, I put some, try to show it here, some tensioning devices to come down and put pressure on those. You can see them right in there. And this screw, this screw here, it's gonna hold that tensioning device in place. It also goes through here and into the mid part of the body to clamp it all together. I've not tried this before. We'll see. Guess it would help if I put it on there right side forward. If it's on there like that, now I have to get in there and screw those 3mm by, what did I say, 16? Yeah, so I'm not going to put you through that. Well, I ran those 16mm screws in there, and my tensioning devices seem to be working. The arms are posable. The next thing to do is to mount the motor, the head rotation motor. To do that, I'll use these screws here. They're 30mm long. They're kind of oddball screws. They've got a Phillips drive on them. So I'll put those two screws in. Well, here he is with his top part put on, and the motor mounted that rotates the head. The hat is held on by magnets. There's a place in here for 1.5mm magnets to hold the top on. Just need to make sure you get them in the right polarity so they attract each other. Not sure if I've mentioned it before, but this gear right here is sandwiched. Here's an older part. Is sandwiched around this ring that rotates the head. So this part and the gear sandwich this in between them. And these 4 screws hold the gear in, the split gear. The gear is made in 2 parts. These are the eyes. I printed those in 2 colors, black and white, because it's a pretty simple print. These are the ears. They're just inserts that are glued in, super glued. Works just fine. The back part, I've placed pockets here for 1.5 by 6mm magnets, just like the top. I'm not sure I'm going to need them. I haven't added them to this yet. The part I release, it will have a place in here that mates to these. You can put magnets in this too. But frankly, it fits so snug, I'm not sure it's necessary. But I'll add them just in case. You can see it kind of, when it goes together down in there, you have to line it up good. This part edge here will mate up against that, And at the very bottom down there, it'll go into little pockets also. The sound.
Vincent's my name, sharpshooting's my game.
I have to decide if I'm going to put the speakers under here. I may put a few holes here to let some more sound out. I probably will. The only thing left other than that is I got to put the little hands or grippers on. I have to print those out still. That's my final thing to do. I'll get that done.